So now we're going to take the idea of extreme values, or being able to find the maximum values on an interval, and use that to optimize some word problems. And optimize just means looking for the best solution given the parameters of the question. So we're going to start with 600 meters of fencing is available to make a three-sided enclosure. All lengths need to be at least 50 meters. Find the dimensions that will maximize the area. So more than likely we have some sort of building, and we're going to be putting three sides of fencing. Now, it's always a better idea to introduce a variable to the most like things. Those two lengths are going to be the same, so that's going to be x. So I'm going to say let x be the width of the enclosure. Now, I have 600 meters of fencing, and so I've used up 2x. So this length is going to be whatever 600 take off 2x's is going to be. And find the dimensions that will maximize the area. Area, this is a rectangle, is length times width. So it's going to be 600 times 600 minus 2x. Our two dimensions multiplied by each other. Order doesn't matter. But here's where I have to be careful. These are going to have intervals involved, like we did the examples in the first video. It says all lengths need to be at least 50 meters. That means this needs to be at least 50. So x is bigger than or equal to 50. But that also means that this length here has to be at least 50. So 600 minus 2x has to be at least 50. I can solve this for x by bringing the 600 over, subtract it. That's where I got negative 550. Then dividing by negative 2, and that's where I got 275. But don't forget to maintain equality, or to maintain the truth of an inequality. If you divide by negative, you have to flip the sign. So here's my interval. X is between 50 and 275. So I have to remember to test those endpoints after I solve this question, because A is going to be 600x minus 2x squared. So now the derivative of A with respect to x, you can do dA dx. We can also use what's called prime notation. A prime, or A derivative, is going to be 600 minus 4x. We need to solve that equal to 0, because at a local max or min, the slope of the tangent is going to be 0, and we're looking for a max for this question. So I get 600 minus 4x. If I solve this, it's going to give me x is equal to 600 divided by 4, which is 125. I look at 125. No, that's not quite right. Sorry about that. 600 divided by 4, 150. Having a rough day with my numbers. So x equals 150. 150 is within this interval. So I'm going to find the a's at 50, because that's an endpoint. A at 150, because that's a potential extreme value from my solving. And A at 275. Remember, be careful to skip over and go to your A formulas, not your A prime formulas. You can use either one of these. I'm actually going to use this top one because it'll be easier to calculate, because I'm going to have 50 minus 600 minus 2 times 50. So that's going to be 50 times 500. I don't trust myself today with the numbers. So 25,000. 150 is going to be 150 times 300, 600 times 2 times 150, which is 45,000. And then I'm going to test 275, which is going to be 275 times 50. 2 times 275 is 550. 600 minus 550 is 50. And that's 13,750. So if they're asking me to minimize the area, that would be my answer. But they've asked me to maximize the area. So I'm honing in on that one. So that tells me x is 150. So this is going to be 600 minus 2 times 150, which will be 300. So find the dimensions that will maximize area. To max area, use 150 meters by 300 meters. So once you have the equation, it's the steps from the first video. Find the derivative, set it equal to 0, take those points that are within your interval and your interval end values, and sub them in to solve. Okay, example number 2 is going to be a little bit strange. It's a little bit more theoretical. It's not practical like the first one, but it is a neat example. So we have an 8 centimeter piece of wire. It's going to be cut somewhere along the wire into 2 pieces. It might be cut in half, it might be cut with one long and one short, but it's going to be cut into 2 pieces. One piece is going to make a circle, the other piece is going to be formed into a square. Where should it be cut? Should it be cut in the middle? Should it be cut towards one end in order to minimize the area and maximize the area? The nice thing is this is not really 2 different questions. In the first example, we could have answered max or min based on the work we did. So that's going to happen here. So the first thing I'm going to start with is my formula, area. Area for this is going to be a circle plus a square. Well, for a circle, it's pi r squared. For a square, it's just side squared. But the problem is I need one variable. There's too much happening here. So I'm going to pretend that I'm going to cut this wire, and I'm going to let x be one of the length or one of the pieces. So let x be length of one piece. Then 8 minus x is the other. And it doesn't matter which one is the longer one and which one is the shorter one. One is x, then the other is going to be 8 subtract x. And those are the length. Now, that means the perimeter of each of these shapes is going to be this. If 8 minus x is the circle, then the circumference of the circle is going to be 8 minus x. If x is this piece of wire, then all of these 4 pieces together have to equal x. Now, because I need to do that to get in here, I want this whole equation defined with relation to x. Well, the circumference of a circle is 2 pi r. So this tells me that the radius is going to be 8 subtract x divided by 2 pi. My circumference is 8 minus x. The formula for circumference is 2 pi r. If I take the 2 pi over and divide, I get r equal to 8 minus x over 2 pi. So instead of having r squared for my circle formula, I can write 8 minus x equals 2 pi. Same thing over here. If x is my perimeter, then 4 times whatever the side is going to be my perimeter, or the side length is x divided by 4. So over here, I can have x over 4 squared. It's not the prettiest thing in the world, but I'm going to clean it up a bit. So I'm going to have pi times 8 minus x squared over 4 pi squared. So I squared the top, squared the bottom. I haven't actually FOILed the top, but I did square 2 to get 4 and pi to get pi squared. And this is going to get x squared over 16. Now I can cancel this pi with one of those. So I get 8 minus x squared over 4 pi plus x squared over 16. So that's my formula for A. And here's where I have to think about my interval. And this one's a little bit different. Now, it's more theoretical. So the biggest x could be is 8. So I could slide this slider all the way over there. It would mean that I really don't have a circle, which makes this more of a theoretical question. But the biggest x could be is 8. The smallest x could be is 0. So I come up with that with the fact that the wire is 8 centimeters long. X has to be somewhere between 0 and 8, because now I'm very carefully going to find this derivative. Now, 4 pi is a constant, so it's just going to stay there. Same with the 16. They're constant, so this is not quotient rule. There's no variables in the bottom. I'm going to do the derivative of x squared first because it's a little easier. I get 2x. Now I'm going to do the derivative of 8 minus x squared using chain rule. The 2 comes down in front. I leave 8 minus x the same, and I get 1. But then I have to multiply by the derivative inside, and the derivative of 8 minus x is negative 1 because my x is negative. Now I'm going to keep working on the question. I'm going to go to line paper for it. So I had a prime as negative 2, 8 minus x, all over 4 pi, plus 2x over 16. So all I did there was multiply the 2 and the negative 1 together. Remember, we want to solve that equal to 0. Well, the best way to do that is to get a common denominator. So if I have 4 pi and 16, my common denominator is going to be 16 pi. So this one I have to multiply by 4, and this one I have to multiply by pi. So I'm going to get negative 8, 8 minus x, plus 2 pi x, all over 16 pi. So I found a common denominator of 16 pi, so I can write them both over 16 pi. Because now that 16 pi is a division. I can think about bringing it to the other side and multiplying, but that's still going to give me 0. So the 16 pi came out. Now I don't have to worry about it. I'm just going to solve the top. So I'm going to multiply that in. I'm going to get negative 64 plus 8x plus 2 pi x, and that equals 0. I'm going to bring the 64 over because it doesn't have an x. These two terms have an x, and I'm going to common factor out the x to get 8 plus 2 pi. So x is 64 divided by 8 plus 2 pi. Now it is better to work with this as a fraction. You could type it into your calculator and go 64 divided by bracket 8 plus 2 times pi, close the bracket, and get a decimal equivalent, but I'm going to leave it like that because it is between, and we can check it. In fact, I'm just going to get what it is so I can get a picture of it. So 64 divided by bracket, 8 plus 2 times 3.14, it's 4.48 or 4.5. 4.5 is absolutely in our interval. Remember, we talked about this. Our interval is between 0 and 8. And I've had a change of heart. I'm actually going to let you work with the 4.5 because now we have to go back to our A formula. I'm going to go back to this one right here. So A is 8 minus x squared over 4 pi plus x squared over 16. I'm going to do A at 0, A at 4.5, and A at 8. So when I put 0 into here, that's going to give me 8 minus 0 squared, which is going to be 64 over 4 pi plus 0 over 16. And if I figure out what 64 divided by 4 times pi is, it gives me 5.1 if I round. I'm going to do the same thing with 4.5. 8 minus 4.5 is going to be 3.5. I'm going to square it and divide by 4 pi. And then I'm going to do 4.5 squared divided by 16. So 3.5 squared divided by bracket 4 times 3.14 equals, so the first part is like 0.97 or 1. 4.5 squared divided by 16 is 1.3, so that equals 2.3 for an area. And then A of 8, 8 minus 8 is 0, so I'm going to get 0 over 4 pi plus 64 over 16, 8 squared, which is going to give me 4. So now, here are my dimensions. And remember, these are my x values. So here's my maximum area of 5.1. Here's my minimum area of 4. So x is the perimeter, or how much is used to make the square. 8 minus x is how much is used to make the circle. So to maximize the area, we're going to cut it at the end, which is kind of weird because it means that we're not going to cut it at the all, but we're going to use all for circle. Because this will be 0, that will be 8, and 8 goes all to the circle. For min, we're also going to cut it at an end. We're going to cut it at the other end and use all for square. Because now x is going to be 8 and then that'll give me 0 left over for the circle. The one in the middle actually gave me the middle value and didn't work out at all. A very strange example because it's not really real life, but it's theoretical and it works with the formulas. So we'll look at one more. A store is being built with a floor area of 3,750 square meters. 3 walls will be in cement, so we're going to have cement walls around the sides and back, and the front wall needs to be glass. The glass costs double the cement. Find the dimensions that will minimize the cost of the building, and the glass wall needs to be between 30 and 60 because it has to be a given size. So because the glass wall has to be between 30 and 60, I'm going to let X be the length of the glass wall. So this is going to be X. And right away I know 30 is less than or equal to X is less than or equal to 60. They gave me that in the question. But now I want a way to figure out the length of those. Well, if I think about this temporarily as Y, X times Y has to be 3,750 because it's area of a rectangle. Well, that means that that other length Y is 3,750 divided by X. So I have my 2 dimensions now both defined in terms of X. Find the dimensions that will minimize the cost of the building. Well, the height is not really in determination because it's how long these walls are going to be that's going to affect the cost of it. So I'm going to let C be cost of cement.
And here are your afternoon announcements. Just a reminder that tomorrow we will have an